is a 100 watt bulb brighter than a 60 watt bulb? We know the energy change taking place in each bulb. We know each bulb is changing electrical energy into heat energy and light energy. The 100 watt bulb is brighter than the 60 watt bulb simply because it's performing that change faster than the 60 watt bulb is. So each second more electrical energy is changed into heat and light in the 100 watt bulb than in the 60 watt bulb. That difference in the speed at which the energy is changed is called the power of the device. And we can calculate the power by measuring the energy transformed and dividing it by the time taken. Energy and power. What do we know about energy and what do we know about power? Well, for energy, we know the law of conservation of energy tells us what we can and can't do with energy. We know that energy cannot be created, it can't be destroyed, it can only be changed from one form into another form. We know that for anything to happen anywhere in the universe, some energy has to be transferred or transformed to make that happen. And we also know that energy is measured in joules. Power, our definition for power is the power of a device is a measure of how quickly it is changing energy from one form into another form. Power is different from energy, so we need different units for it, and so power is measured in units called watts. The symbol is capital W. We can use the triangle here to manipulate the formula. P is power, E is energy, and T is time. Okay, here's a question we can have a go at. Can you calculate the power of a light bulb if it transforms 3,600 joules of electrical energy each minute? Well, I need to calculate power. I need P equals, well, I can look at my triangle, cover up the P, and I've got E energy over T time. So P equals energy over time. So I can look in the question to find out what the energy is and to find out what the time is. And here I've got the energy, and here I've got the time. But they've tried to trick us here because they haven't quite given us the time in the right units. To use the formula, I need the time in seconds. So 1 minute is 60 seconds. So I've got 3,600 joules in a time of 60 seconds. So I can put that into the formula to get 3,600 divided by 60. So that gives me a power of 60, and I need to remember the units, watts. Okay, let's try another question. How much electrical energy will a 2 kilowatt heater transform if it's left on for 10 minutes? This time the question is asking me to work out energy. So I need E equals something. So if I go to my triangle, cover up the E, so it's P times T, so that's got to be power times time. So I need to find the power and the time in the question. So 2 kilowatts is the power and 10 minutes is the time. So again, they've tried to trick us with the units, so I need to change 2 kilowatts into watts. Well, 1 kilowatt is 1,000 watts, so 2 kilowatts is 2,000 watts. and I need this in seconds, so 1 minute is 60 seconds, so 10 minutes must be 600 seconds. Okay, so put that into the formula. So energy equals the power, which is 2000 watts, multiplied by the time, which is 600 seconds. So the energy will equal and I need to remember my units now. This is an energy, so it must be in joules. Okay, just to sum up then, we know that power is how quickly energy is being changed. We know that the formula for calculating power is the amount of energy changed divided by the time taken. Power is measured in watts, and when we're doing calculations we need to make sure that the power is in watts and the time is in seconds. We can use our triangle